Hello and welcome back to the course on R programming. I hope you had a chance to play around with the matplot function and that you were able to create some impressive charts. And as you can tell, it's getting pretty exciting already. We're working with charts, we're looking at the basketball data. What's coming up next, right? So what we're talking about today is subsetting. Subsetting is a very important topic in R, and actually a lot of R users get it wrong. In fact, some R programmers can go for years without knowing exactly what a subsetting is and how it works, thinking that they do know it until they run into a problem one day, and then only they find out about subsetting. So today I want to make sure that you will never ever end up in a situation like that, and that's why we're going to get this topic down pat. All right, so let's go to a new file, and the way I want to introduce this topic is through something you already know. So we've already talked about using the square brackets with vectors. So let's create a vector, and in that vector we'll just put 5 values, just 5 letters. And if we run this vector, there they are, those are our 5 letters. Now we know that if we want to extract just the first and the fifth letter, then to do it we need to type in x, square brackets, then c, 1 and 5, because c1 and 5 is just the values 1 and 5, and this over here tells R that we want to extract the first and the fifth value from this vector. All right, great. So if we want to extract just one value, if we want to extract just the first value, then we would do a similar thing. We would type in x, square brackets 1. And we're pretty comfortable with that already. Now, the interesting thing is that what we're actually doing is we're actually subsetting the vector x, right? So originally we had a vector of 5 values, then we have a vector of 2 values, and finally we have a vector of just 1 value. And we know that this is a vector because we've talked about that in R, even a single variable is stored as a vector. Okay, so every time you subset a vector, you get a vector. Great. But now let's look at a similar concept with matrices, because you can also subset matrices. Let's say we look at the games matrix that we've been using so far. And these are the games that the players have played. Now let's say we want to look at just a subset of this matrix. Let's say we want to look at the first 3 players, or the top paid players in the NBA, Kobe Bryant, Joe Johnson, and LeBron James. And we want to look at their stats, or the number of the games they've played, only for the past 5 years. So 2010 to 2014. How would we write that? Well, it would be very similar to what we've been doing with the vector. We would type in games, then we would put in square brackets, and then for rows, so there's our comma, for rows we would say 1 to 3, and for columns we would say 6 to 10. So if we run that, we get the first 3 rows and the 6th to 10th columns, exactly what we wanted. And this time it looks like the subset of a matrix is also a matrix. Great. Now let's try another example. Let's say we want to compare the top paid player in this list and the lowest paid player in this list, Kobe Bryant and Dwayne Wade. So how would we do that? And we want to compare them across all of the years, the number of games that they've played. Well, the way to do that is to say games, and then in square brackets we would say C, 1 and 10, right? So we want just the first and the 10th rows, and then for columns we just leave a blank. And we've also talked about that if you want to select a certain row, then you just type in the row number, comma, blank in the square brackets. And that's exactly what we're doing. We're just selecting 2 rows here. If we run that, we get the first and the 10th row. And once again, we get a matrix. And one more example like that would be if we want to select, let's say 2008, 2009, we just want to analyze those 2 years and for all of the players. Then we would say games, in square brackets we would type in blank, comma, C, and this time instead of counting out every single column, we would just type in the names of these columns, because that's another thing we talked about. We know that we can use names in named objects, and in this case it would be like that. If we run that, we get a matrix, again, all of the rows and just the 2 columns that we wanted. Okay, so far so good. Looks like every time we subset a matrix we get a matrix. However, it's not always the case. So let's look at another example. Let's say we want to extract games, and we just want to extract the first row, just Kobe Bryant. If we say 1 comma blank and we run that, we get something similar, something that looks like a matrix but not quite. So if we compare it to this matrix here, you can see that this matrix has row names. This matrix doesn't. Why is that? And is this a matrix in the first place? Well, actually it isn't. And we can prove that if we simply run the isMatrix function and we take this, our new object, and we put it in the isMatrix function, we check. We get false. Why is that? Well, because it's actually a vector. If we check vector, isVector, we get true. Interesting. Okay, let's have a look at another example before we explain that. Let's say we want games and we just want one value. Let's say we want Kobe Bryant, so the first row, and for 2009, so the fifth column. We would go games 1 and 5, and we run that. And so we got the one value, but it's not a matrix for sure. It's a vector again. So what is happening here? Why are we getting vectors instead of matrices in these two cases? Well, what's going on is actually the square brackets have this specific quality to them, which a lot of our users might call a flaw, but in reality, it's just how the language was designed. So what is going on? Well, R is trying to guess what you want. So in all these instances, obviously you want a matrix because you're getting a two-dimensional object. But here and here, your object is no longer two-dimensional. So R thinks, well, maybe what you were after was actually a vector. And it returns you a vector. So in this case, it's a named vector. It's got the elements are named. In this case, you just get a vector of one value, 73. And why does R do that? Well, because let's remember that R is not just a programming language. It's a language for statisticians and mathematicians. And there's always going to be this trade-off between programming and following strict rules and procedures and fast, agile analysis of data. So in this case, R is guessing that in most cases when you would want to extract a one-dimensional object from a matrix, you would want a vector. You wouldn't want a matrix. So that's why it's doing that. How do we fix that? Well, to get the default behavior of the square brackets, and by the way, the default behavior of the square brackets, and probably default is not the best word. The best word here would be to get consistent behavior from the square brackets, there's another parameter that you can specify. So in order to get to that parameter, you need to add another comma. So this is your rows, then you've got comma the columns, and then there's a parameter which is called drop. And drop by default is set to true. So what it does is, you can see here, is delete the dimensions of an array which have only one level. It drops unnecessary dimensions. So by default it's set to true. Let's set it to false. If I run this now, you will see that now I have a matrix instead of just a vector like I had here. And what's going on is that R is no longer dropping this dimension. So R would drop any dimension where it's only one. In this case, Kobe Bryant is the only row, and R would just drop that dimension and turn this vector into a matrix into a vector. So here, I can do the same thing. If I say drop equals false, I run that, then I get the consistent behavior from the square brackets, and I get a matrix. So if you type in drop equals false, then the square brackets will always return the same class of element or object as you had originally. In this case, we had a matrix, so we're getting back a matrix. Okay, so that is how subsetting works, and it's important to know about these things. Just remember that whenever you're using the square brackets, R will try to guess what you want. If you don't want R to guess, then don't forget about this let's call it a secret argument that you can pass to the square brackets called drop. And if you set it to false, then you will get the same class of object as you had originally. Hope that's useful, and I'm sure that one day this knowledge will come in handy. And now let's move on to the next tutorial. I look forward to seeing you there. Until then, happy coding.